Ever wondered about the moon's hidden mysteries? Renowned physicist Michio Kaku recently revealed astonishing findings from India's ISRO Chandrayaan-3 mission, and the results are nothing short of groundbreaking. This historic mission not only confirmed the presence of lunar water ice, a potential game-changer for future lunar colonies providing drinking water, breathable oxygen, and even rocket fuel, but also uncovered several other remarkable discoveries that have left the global scientific community in awe. In this video, we'll explore what Chandrayaan-3 has found so far, its significance, and why it's reshaping humanity's understanding of the moon. Before diving into the discoveries, let's look at an awe-inspiring video of the Pragyan rover making its descent onto the lunar surface, filmed by the Vikram lander's onboard camera. The footage shows the rover carefully rolling down a ramp, approaching the moon's surface with precision, as mission controls beeps and updates echo in the background. Because of the 2.6-second communication delay between Earth and the moon, both the Vikram lander and Pragyan rover had to operate autonomously, relying on their own onboard computers and sensors to ensure a flawless landing. This incredible video highlights the seamless teamwork between the two robotic explorers. After the successful landing, Pragyan captured an iconic image of Vikram standing proudly on the moon, marking India's triumphant entry into the elite club of lunar nations, joining Russia, the USA, and China. Landing on the moon is no small feat. It demands absolute precision in timing, navigation, and speed control, where even the smallest error could result in catastrophe. This image is not just proof of India's success. It's also a heartfelt tribute to Dr. Vikram Sarabhai, the visionary founder of India's space program in 1969, whose legacy continues to inspire generations. Another video released by ISRO shows the Pragyan rover navigating the moon's rugged terrain, powered by sunlight through its solar panels. Its mission focuses on exploring the lunar South Pole, an area of immense scientific interest due to its unique composition and potential water reserves. Despite challenges like low gravity, uneven terrain, fine lunar dust, and extreme temperature fluctuations, Pragyan's advanced systems, including its suspension, sensors, and thermal control unit, allow it to traverse the surface safely and efficiently. Using its laser-induced breakdown spectroscopy (LEBS) instrument, Pragyan analyzed lunar soil and made a surprising discovery: a high concentration of sulfur in the moon's South Pole region. This element, vital to both life and volcanic activity, offers clues about the moon's geological evolution and even points to possible meteorite impacts in the region. Alongside sulfur, elements like magnesium, aluminum, silicon, calcium, titanium, iron, and sodium were also detected, providing valuable insight into the moon's composition and history. Meanwhile, the Vikram lander's chased instrument measured dramatic temperature variations, from a frigid -156 degrees Celsius at night to scorching 121 degrees Celsius in daylight, confirming the South Pole as one of the most extreme environments on the moon. After completing its objectives, Vikram and Pragyan were placed into sleep mode to endure the harsh lunar night, with hopes of reactivation once sunlight returns. Chandrayaan-3's success marks a monumental leap for India's space program, but ISRO isn't stopping there. Soon after the moon landing, India launched the Aditya L1 mission to study the sun from 1.5 million kilometers away, joining the ranks of NASA, ESA, and JAXA in solar research. This mission seeks to unravel mysteries like coronal heating and the sun's influence on planetary atmospheres and space weather. India's achievements, from the moon's South Pole to the sun's orbit, reflect its growing prowess in space exploration. With future plans to send astronauts into orbit by 2025, India is steadily cementing its place as a major global space power. The discoveries of Chandrayaan-3 not only deepen our understanding of the moon but also inspire humanity's next great leap beyond Earth. The Pragyan rover is a remarkable piece of technology, capable of communicating not only with the Vikram lander, but also directly with Earth via radio signals. However, don't be fooled by the seemingly simple act of moving across the moon's surface. It's anything but easy. The rover faces a series of formidable challenges as it navigates the harsh and unpredictable lunar terrain. These challenges include low gravity, uneven surfaces, pervasive dust particles, and extreme temperature variations. Each of these obstacles demands clever engineering solutions, and Pragyan is equipped with exactly that. First, there's the issue of low gravity. The moon's gravity is only about 1/6 of Earth's, meaning Pragyan weighs significantly less on the lunar surface. While this might sound like an advantage, it actually creates problems with traction and stability. To overcome this, the rover is designed with a special suspension system that allows it to adjust its height and tilt depending on the terrain. It also moves at a carefully controlled maximum speed of 1 centimeter per second, ensuring steady motion without losing balance or tipping over. Next comes the challenge of uneven terrain. The moon's surface is rough, rocky, and filled with craters, hills, and valleys, making navigation extremely difficult. To handle this, Pragyan relies on advanced navigation technology, including high-resolution sensors, cameras, and algorithms that map out the surrounding landscape and plan the safest route. It even has a hazard avoidance system that detects and steers clear of obstacles like large rocks or steep slopes, essentially a highly intelligent GPS designed specifically for the moon. Another major challenge is the fine lunar dust that blankets the moon's surface. These microscopic, sticky particles can cling to everything, posing a serious threat to Pragyan's delicate instruments. Dust can block its solar panels, reducing power efficiency, or obscure its cameras, limiting visibility. To combat this, the rover is equipped with a dust protection system that uses brushes, blowers, and heaters to keep its components clean and operational throughout the mission. Finally, there's the problem of extreme temperatures. The moon experiences dramatic temperature swings, from a freezing -156 degrees Celsius during the lunar night to a scorching 121 degrees Celsius under direct sunlight. These extremes can easily damage electronics and mechanical systems. To survive, Pragyan uses an advanced thermal control system combining insulation, radiators, and heaters to maintain stable internal conditions, ensuring it functions properly regardless of the lunar environment. In essence, the Pragyan rover is far more than a simple robot. It's a marvel of modern engineering, built to endure and adapt to one of the most hostile environments known to humankind. With intelligence, resilience, and curiosity, it continues to explore uncharted regions of the moon, seeking to uncover its secrets and expand our understanding of its composition and history. Now, shifting our focus to its scientific work, let's look at something truly fascinating, a graph revealing the chemical makeup of lunar soil. This data comes from Pragyan's laser-induced breakdown spectroscopy (LEBS) instrument, one of its primary tools for analyzing the moon's surface. The LIBS system works by firing powerful laser pulses at small samples of lunar soil, generating tiny plasma bursts that emit light. By examining the colors of this light, the instrument can determine the elements present in the sample. Through this technique, Pragyan studies the soil composition of the moon's South Pole region, a scientifically unique area with characteristics distinct from other lunar zones. These findings not only help scientists understand the moon's geological history, but also pave the way for future missions aiming to utilize its natural resources for sustainable space exploration. The South Pole region of the moon has become a focal point of global scientific curiosity and exploration, and for good reason. As noted by theoretical physicist Michio Kaku, this area is not only historically and scientifically significant, but also holds immense potential for the future of lunar and space exploration. Many nations are now competing to explore this region because it could one day serve as a strategic base for deeper space missions. One of the most compelling reasons for this interest is the discovery of water at the moon's South Pole, a finding that could transform the future of human space travel. Water, as Kaku explains, could be used to produce fuel for rockets and spacecraft, making sustained missions to the moon and beyond far more feasible. Beyond water, analyzing the lunar soil composition in this area offers crucial clues about the moon's origin, evolution, and geological activity. During the Chandrayaan-3 mission, scientists uncovered a surprising revelation: a high concentration of sulfur in the South Pole soil. This discovery is particularly intriguing, as sulfur is an essential element for life, forming part of key biological molecules such as amino acids and proteins. Moreover, sulfur is commonly linked to volcanic activity, often found in magma and lava, and its presence could even point to ancient meteorite impacts, since many meteorites contain this element. The detection of sulfur is therefore not just exciting. It could reshape our understanding of the moon's geological history and open new possibilities for future exploration and even colonization. But sulfur isn't the only noteworthy finding. The Pragyan rover also detected several other important elements on the lunar surface, including magnesium, aluminum, silicon, calcium, titanium, iron, and sodium. According to Michio Kaku, these elements serve as vital clues to unraveling the moon's geological past and understanding how it has evolved over billions of years. Meanwhile, the Vikram lander, which played a critical role in the Chandrayaan-3 mission, has made significant contributions of its own. After successfully completing its scientific objectives, the lander was placed into sleep mode, but not before capturing invaluable data about the moon's surface temperature. This was achieved using an instrument known as CHAST, Chandra's Surface Thermophysical Experiment, designed to measure the temperature characteristics of the lunar soil near the South Pole. By taking readings at various depths, CHAST helped scientists create a thermal map of the moon's subsurface layers, a major milestone in lunar science. The data revealed that temperatures in the South Pole region fluctuate dramatically, plunging to -156 degrees Celsius at night and soaring to 121 degrees Celsius during the day. This makes the South Pole one of the moon's most extreme environments, posing major challenges for both human survival and robotic operations. The Vikram lander was therefore engineered to function for only one lunar day, roughly 14 Earth days, allowing it to complete its mission before the freezing lunar night set in. During these nights, temperatures can drop to a staggering -183 degrees Celsius, cold enough to freeze the rover's instruments and systems completely. The Indian Space Research Organization, ISRO, confirmed that before entering sleep mode, all of the rover's instruments were safely powered down and the collected data transmitted back to Earth via the lander. Currently, the batteries remain fully charged and the solar panels are positioned to capture sunlight once it returns, expected around September 22, 2023. The communication receiver remains active, awaiting the first rays of dawn that might reawaken the lander and rover, marking a new chapter in India's remarkable lunar exploration journey. Scientists remain hopeful that the Pragyan rover will successfully wake up from its sleep mode and continue its operations on the moon's surface. If reactivated, Pragyan's next mission will focus on searching for water ice and traces of hydrogen, crucial resources that could one day be used to produce both drinking water and rocket fuel for future lunar missions. While the rover's revival remains uncertain due to the harsh lunar environment, its potential return would mark another milestone in India's growing achievements in space exploration. Meanwhile, India's space program has already taken another bold leap forward by launching a mission to study the sun up close. Just a little over a week after making history with a successful Chandrayaan-3 lunar landing, India launched the Aditya L1 spacecraft from the Sriharikota Space Center in southern India. The mission's goal is to observe the sun from a stable orbital point about 1.5 million kilometers, 930,000 miles, from Earth, known as Lagrange Point 1 L1. This unique vantage point allows for an uninterrupted view of the sun, making it ideal for continuous scientific observation. If successful, India will join a select group of nations, including the United States, NASA, the European Space Agency, ESA, China, and Japan, that have sent dedicated missions to study the sun. But why study our star so closely? The answer lies in the sun's immense influence over Earth, other planets, and space weather. Solar activity, such as solar winds and flares, can disrupt satellites, communications, and even power grids on Earth. Scientists also believe that solar winds may have stripped Mars of its atmosphere, transforming it from a once potentially habitable world into the barren planet we see today. The Aditya L1 mission seeks to uncover the mysteries of coronal heating, a puzzling phenomenon where the sun's outer atmosphere, or corona, is millions of degrees hotter than its surface. This mission aims to collect unique, never-before-seen data about the sun's magnetic fields, solar radiation, and energetic particles. According to Shankar Subramanian K., the mission's principal scientist, Aditya L1 will help researchers better understand the sun's dynamics and the inner heliosphere, which plays a crucial role in shaping space weather and protecting modern technology. India's space ambitions have been steadily rising for over 2 decades, and the momentum continues to grow. With 3 successful lunar missions, a mission to Mars, and now a solar observatory, India has firmly established itself as a technological powerhouse in space exploration. The country's next major goal is to send astronauts into orbit by 2025, further cementing its place among the world's leading spacefaring nations. India's journey into space is nothing short of inspiring, a story of innovation, perseverance, and global leadership. And with every new mission, the nation continues to prove that its space program is one to watch. Thanks for watching, and don't miss the next thrilling video coming up on your screen.